All right, you guys need more time to decompress? That was tough. I'm just kidding. It was a good talk, just very cerebral. Mine will be significantly less. So, I'm here to talk about the Smack Stack, a little bit about the technology and why I chose it. So, a little bit about me. I'm Andrew Mills. I'm a software architect for a company called Sykes. Work from home. We got about 50,000 employees, and our primary role is we take phone calls. Uh, Mostly, I do Microsoft development, C#, .NET, JavaScript, and SQL. With the last year, though, in this Smack project, was my first introduction into Linux and Java and all that fun stuff. So, my primary focus is internal based, not really customer facing applications, things that help the business. So, the particular problem that I was trying to solve is since we have so many call center agents, all the actions that they take throughout the day are logged. And so the business came to me and said, we need to be able to process events in real time and then store it into a database and then send it to our Azure Event Hubs so that our analytics teams can do sentiment analysis and do other types of analytics on the data and provide kind of real-time feedback to those agents. And they expect that once we ramp up this load, we'll have about 500 million transactions a day flowing through this system. And so they need it to be super resilient, self-correcting, and always on. We have kind of a initial proof of concept that was out there, and it was an ASP Web API built in, and then had a Microsoft SQL Server for the database. And then there was like a little console app that would reach into the database and kind of worked it like a queue, right? It would grab a few records, it'd send them off to Azure, and then mark them as done, and then grab the next batch. Well, we got to about 1 million transactions a day, and that started to cause problems. You got concurrency issues and locking and all sorts of issues where, something was trying to write into the table, and you got something trying to update 100 rows and this and that. We tried lots of different ways to get around it, but we realized pretty quickly there was no way that pipeline would scale to 500 million transactions a day. So I did some research and kind of in came the Smack Stack. So what is Smack? It stands for Spark, Mesos, Akka, Cassandra, and Kafka. Personally, we only use 3 of those. We do not use Mesos, which is a cluster manager, and we don't use Akka. Technically, Spark is built on Akka, but we don't actually use it. So obviously, you can read here, but what is Spark? Spark's a fast general engine for large-scale data processing. We don't use Spark yet as Spark that you may know, but we use Spark Streaming, which allows you to hook right into an event processor, which is Kafka, the streaming processing platform, and listen to that data stream, and then do Spark type analytics on that data, which is the kind of the long-term goal. Right now, we're just kind of using it to push the data to different places, but eventually, with that, you can do some like fraud detection type stuff, or we could do some of the things that we're doing later down the pipeline at this kind of level in the stack. All of these projects, except for Akka, are open source projects through the Apache, and so you can technically implement them all completely free. You just don't get any enterprise level support. Obviously, you'll get community support if you just want to play around. But when you're working at the enterprise level, it doesn't work out very well. When you're down in the middle of the night, you need enterprise support. So in comes DataStax. So DataStax is a company that created Cassandra. They offer enterprise support for Cassandra. And they have a tool called the Ops Center that manages, they have a tool, a suite called DataStax Enterprise, which you can use to fully install your Cassandra cluster. It'll also run Spark in that cluster, and it connects it directly to the Cassandra database, and it all runs in the same JVM and all that stuff. So it's a lot faster to communicate that way than it would be if you did a standalone Spark and a standalone Cassandra. DataStax offers free training, which is actually pretty good, but they do also have certifications you can get. So they're a great company to work with. We've been working with them for about a year and have really enjoyed them so far. The language and infrastructures that I'm working with is right now all of our VMs are in, all this infrastructure is set up in Azure VMs. And it's a 3-node cluster, and there are 8 core 64 gigs of RAM sitting on SSDs for each of those nodes. Technically, because I'm running Cassandra and Spark, they suggest that you have 16 cores and 128 gigs of RAM, because there's so much in-memory stuff happening, and you'll see later how you can allocate cores, specific cores, to individual processes, which makes like Spark streaming way faster. And then it's sitting on Linux RHEL 7.2. The Spark job, or Spark streaming job, was written in Java. They do also have several other languages that you can write it in, and the API that's kind of the front end from the client data gets shipped over to the API. That's in Node.js. So here's a little bit about the actual flow of the data. So you have the reps that are taking calls, and we're collecting information. It's sending it to the API. The API then publishes the event into the Kafka queue, or the Kafka, I can't think of it, hub, if you will. Then Kafka, then you have the Spark streaming jobs that subscribe to the different topics in Kafka. And when a new event is published, it is then picked up right in Spark streaming. Spark streaming does some stuff with it, some data enrichment, and kind of processes the records. And then it sends it out to both the Cassandra database for short-term storage, and then it sends it to the Azure Event Hub, which is where our analytics team works and does lots of other fun stuff with it. And then finally it sits in a data lake out there in the Azure Event Hub. But that's kind of how it works. I want to quickly show you just some of before I move on, was there any questions real quick about that? We went through it pretty quick, so. All right, I'll show you some of the stuff. So this is the actual Kafka queue, and so you can see just events flowing in right now. It's only about 1 million a day, so it's not very much. And I've intentionally, oh wait, that didn't work out as planned. There we go. Made it so you can't read it. Tried to anyway. We'll see how screenshots on the video later go. But that's kind of just the queue, data flowing through. And then as the data flows through, this is the Spark UI, and you can see in here we have several different jobs, Spark jobs, and drivers and applications set up to run and monitor the Kafka queue. And as I mentioned earlier, you can see the different cores that are allocated to it. So I've got 9 cores just allocated to 3 Spark streaming jobs, and these jobs are spread out over the cluster. And so the Spark UI, you go in and you submit the application to Spark, and it will distribute the job across the cluster automatically for you and allocate all the resources. It works pretty well. And then once you've submitted the job, you can come into here and you can get analytics on it, on actually how the job is performing, how many events are coming in per whatever interval, if there's a delay in processing or what they call scheduling, so that there's one main Spark node that then sends the work out to the cluster, and if the cluster doesn't finish the work in time, there's a delay in scheduling it the next kind of set of events or batch of events. And then you can actually come in here and see any active batches that are running, past ones, and you can drill through those to actually get, if there are errors, or you cannot actually see the data in there, but you can get more insight into what's happening with your cluster. And then finally, this is the management tool that DataStax sells as part of their DataStax Enterprise Suite, called Ops Center, and it's really helpful. It can give you more analytics on how your Linux boxes are performing, how well Cassandra is performing inside of those boxes, what type of resource usage you have. You can do a lot of the different actions as part of Cassandra within, clean them, compact, those types of things. You can restart nodes from here. This is a really great kind of DevOpsy tool for them to use. And then Another neat thing is the lifecycle manager that is part of the DataStax suite, which allows you to go in and actually create your cluster. And so you can create it right here through this interface. And then once you've created it all through here, you can just come in here and click install. And as long as you have the right permissions set up and you have all the right IP addresses and all that type of information in there, the lifecycle manager will actually reach out to all those VMs and install Java and then set up everything that you've configured through this UI. So it's really handy. A lot better than having to go mess with the configs on the virtual machines by themselves. So finally, this is the Cassandra database. I just grabbed 10 rows from it. It's very similar to the T-SQL statements that you'd run in a Microsoft environment. Cassandra is a NoSQL database, and the data models really rely, or the speed, I guess you could say, really relies on your data models. You have to have the right data models built in order to get the data out quickly. So there are also a lot of limitations. You can't do like aggregate functions and things like that within Cassandra using CQLSH, which is the Cassandra query language, and this is the Cassandra query language shell. So you can only just do basic select statements here. You have to use a Spark SQL or some other language that would submit kind of a job, like a MapReduce job, if you will, out to your Cassandra cluster and figure it all out. So that's all I got. Just wanted to introduce you to the SMAC stack. Any questions?